Hi Year 10. So in this video what we'll do is we'll just finish off the very last part to the breakfast cereal question, and then we'll have a look at a two-way table, how to draw one and how to use one, and then you're going to get some time to finish off 8b and 8a. Alright, so let's finish off this problem here. So what we were looking for is the probability of A and B or C all knotted. Okay, so the first thing we'll do is we'll look at what is not B or C. Right, so let's clean this diagram up a little bit because it's still shaded from when we were in class. So the first thing I'll do is I'll shade not B or C. All right, so that's everything other than B or C. All right, so what I'll do is I'll shade A only, and I'll shade the outside. Okay, and you can see there what I've done is I've shaded not B or C. So here's B, here's C, and I've shaded not them. All right, now what we're going to do is shade A. All right, so I'm going to grab a different color and shade A, and that is this one here. All right, now remember this is A and, so what I'm looking for is the thing that was shaded in this section here and here, and the only part I've shaded twice is this A only section here. So this basically means A only. All right, so what we'll do is get rid of all of the ancillary shading and just note that this was the only part that was shaded twice, was A only. So the probability here is going to be 14 out of 80, 7 in 40. All right, so now on to Carnot maps, they call them, probability tables. Doesn't really matter what it's called, I suppose. What it matters is what information it shows us. So you can use a Venn diagram, or often you can use a Carnot map or a probability table. And a lot of the Year 12 problems are actually solved with these probability tables, so you'll find them really, really handy. So what do they show? Well, what we do is we write our event here. So we've got event A, and we always write not that event, all right, next to it. Then we've got the other event, which is B, and we've got not B, all right? And the different parts of the Venn diagram can be placed in the Carnot map. So you'll notice that the intersection, this part here, is just placed here. And what we do is we link up these parts here with an and symbol. So this is A and B, all right? So that's where we put A and B. We put the intersection there. All right, this represents not A and B. So this would be B only. Okay, so what we've got there, just change the shading color. That's this part here. That's what we call B only. All right, and that's what we put there. And we've got A only. Okay, and A only is A and not B. That's represented by that. So we'll do that in orange. That's going to be this part here. And the final thing that's represented on a probability table is going to be this outside part here. So I'll choose my final color, fluoro green. All right, that's this outside bit here. And that's going to be not A and not B. All right, so what we'll do is we'll do this one with a Carnot map, or we'll do this one in particular with a probability table. So records show that 13% of Australians are left-handed and 49% of Australians are male. Okay, so the two things we're looking for is left-handedness and male. All right. So what we'll do is mark them down here. We can put either in either section, doesn't really matter, but I'm going to say this is left-handed and this is not left-handed. All right, and we've got male and we've got not male. All right, now let's fill in the parts. So records show that 13% of Australians are left-handed. So this is left-handedness, and males and not males incorporate 13% or 0.13 of the left-handers. All right, so now we note that 49% of Australians are male. So here's male, left-handed or not left-handed. So it's 0.49. All right. And 8% of Australians are male and left-handed. So this is male and left-handed. So it goes here. So we're going to put 0.08 there. All right, so now what you do with the probability table is you write a 1 there because all of these and these will add to 1. So if you're male, or the chance of being male in Australia is 0.49, not being male is 0.51. That's everyone else. We also know that if you're not left-handed, if you're left-handed, it's 0.13. So everyone else is just considered not left-handed, ambidextrous, or obviously right-handed. So that's going to be 0.87. Now, this one here, this is left-handed and not male, okay? And that's going to be the value that is added to 0.08 to get us to 0.13. So that's going to be 0.05. All right, what else have we got? We're going to fill in this one here. That's going to be 0.46 because 0.05 plus 0.46 is 0.51. Right, and this one here is going to be whatever's added to 0.46 to get to 0.87, and that is going to be 0.41. And we just cross-check that with this column here. 0.41 plus 0.08 is indeed 0.49. So we've got all the information. Now it becomes really easy to answer the problem. What is the probability that a randomly selected person is female and left-handed? Okay, so not male is going to be, well, we're going to consider it female in this case, although the example doesn't account for, you know, the growing trend of people neither identifying as male or female, but we won't go into it in this example. So we'll just say that the probability that a person is female and left-handed, we're going to go not male and left-handed. So that is going to be 0.05. You could write that as a percentage if you want, 5%, but it's fine leaving it like that. You could write it as a fraction, 5 over 100. That's a 1 in 20 chance. All right, what is the probability that a randomly selected person is male and not left-handed? So again, this is going to be quite high, okay, because we know that 50% roughly are male, and if you're not left-handed, you're right-handed or ambidextrous, and that's a lot of them, okay? So let's have a look. We're going to say male and not left-handed. It's this one here. So 0.41, you could leave the answer as that, or you could write it as 41 over 100 if you wanted. All right, so there's your two-way tables or probability table example. So make sure you get that into your notes. And what you're going to do now is answer the questions from 8A and 8B. All right.